All right. Well, welcome everybody to the unfortunately last SOTA, short observation data analysis webinar for the Globe ENSO student research campaign. Today is May 31st, 2018, 2 p.m. Eastern Daylight Time. And a couple quick things about some other happenings as part of the campaign. One of I call him the lead, Bob Koenig, for this. It's the Globe ENSO campaign's Global Water Quality Collaboration, and I created a little bit.ly URL there if you can become part of this. It's a great collaboration from schools in the U.S. and from around the globe, around the planet, Globe schools from around the world who are participating in the Globe Water Quality Collaboration. And what this means is that folks are collecting water quality data and sharing that and comparing the data from around the world in different bodies of water. So it's really cool and exciting. This is the bit.ly URL because, as you know, on the Globe website, the URL is pretty huge, and this will take you directly to the collaboration page where there's some threads going on with the different participants. So hope you don't mind if I shared your email down there, Bob, but there's your Gmail email down there. So if you have any other questions, you can contact me or contact Bob at the URL. Anything you want to quickly say about that, Bob?
Yeah, listen, no problem. Thanks a lot. I'll just have to check my email a lot more often now and make sure that I don't miss anything. But yeah, the one thing I do wanted you to do, because it was so hard to say that Global Water Quality Collaboration Group, if you could change it to, we actually changed it to Genesis now, the Global Environmental Network, and I'm trying to remember how I got it together, Evoking Students in Science. So okay. It worked out as a nice Genesis thing. It's a lot easier to say than whatever that other acronym was. So yeah. I'll get in touch with you probably sometime during the week, and we'll see if we can change that.
Okay.
But yeah, good. Thanks for the plug, and hopefully we get more people joining.
Yep, and thanks for the work you're doing, getting some of the schools in other parts of the world some tools, with Dixon and the folks out,
Yeah, it worked out well.
Yep. Thanks, Bob.
No problem.
If you go to the Amazon, you see
all right.
So,
this is where we're going to come through to you from today, Mahopac, New York. I want to make sure I have, okay. So, all right, that one skipped in there strangely. That went the wrong way. But here are some of the active countries that are working in the Genesis Water Quality Collaboration Group. And then here are all the active countries that are participating in the ENSO Phase 3 student research campaign. So we have schools from all over the world. We're hoping to, even bring more and more schools in, as far as working with these countries here as in the water quality collaboration. So, we're looking forward to doing that in the future. So let me jump ahead right here to what we're going to be learning about today. And this is live from Mahopac High School. We have the students on board right now. And they're coming in live from Mahopac, New York, from the high school. And their topic of discussion is a case study, Can Students Affect Water Quality? And here we have Sydney, Tyler, Alex, and teacher, Mr. Scott Rizzo. So I'm going to pass it over to them to do the presentation. And I'll stop sharing my screen. You guys can just share your screen.
I'm Sydney.
I'm Alex. And I'm Tyler.
And we're from Mahopac High School. And our project is called the Genesis Project. And our question is, can students have a real impact on water?
So we live in Mahopac, New York, and it's not really considered upstate like the fields and farm. It's not really the city. That's a little 45 minutes below us. So we live in sort of like this middle ground, and we live really close to the Hudson. And so in Mahopac, we have this huge lake. It's just like this small town kind of thing, and it's a nice town. So each year we get a lot of precipitation. Specifically this year, we've had a lot of snow. We've had something like 12 snow days, like all substantial amounts of snow. And it's cool because then we can see like the impact precipitation has on our wetlands, which you can see here. So we study all 4 seasons. We do year round. So the picture for the spring and summer is actually our post-pond site. And then we also study in autumn when the school year begins. And we also study in winter. The left photo is post-pond from a different angle. And then the right photo is pre-pond. And so each year, naturally, like the water freezes over. And we actually have to break through the ice and get it. Sometimes it's easy where all we have to do is just like stomp through it and it's fine. But sometimes we have to use like hammers and it can get really thick. So, and then we also study like the effects the seasons have on temperature. So like, yeah, it's just basically a cyclic.
As you can see, the temperature drops with winter and raises with summer every single year.
Yeah, exactly. So this is an aerial shot of our campus. So at the bottom of the photo is our school. And then pre-pond is before the pond, obviously. And then after is post-pond. And that's more the right of the picture. Across the street from our campus is Indian Hill. And so basically that's where our stream starts. And these darker spots are just moisture that will eventually go into our stream. And it's really cool for us because as students, like, it's so cool we have this site just like within distance to our school. Yeah. So our stream that's on our campus is classified as a Class C stream. And these are just some of the stuff that we study. And we have to make sure that they stay around measurements and we can be classified as Class C. And then this is the sheet that we use, the data sheet that we use each week when we go out and study. We use the same one for pre and post pond, and we just have to differentiate which one we keep it.
Yeah, so we test for all of these parameters.
Yeah.
So around our pond, around our stream, we have a lot of wildlife and a lot of plants. And so one recently is our invasive versus our native species. We've actually been working with a few organizations near our school, like the Corn Extension and the Watershed Agricultural Council, and people, representatives from those groups have come and talked to us about the species. So you can see our list of invasive species on the left, and you can see the pictures of the bittersweet and the multiflora rose, which are both really prevalent around our stream. And you can see the goldfish in there. About 10 years ago, a girl's dad did not want the goldfish that she had won at a fair, and so they released goldfish into our stream. And
There's still one living there today.
Yeah.
It's very big.
yeah, there's one left. But they've mostly been eaten by a bird that we have, which we'll talk about in a moment. And so you can see our list of native species on the right. And we're really trying to boost our native species and eliminate some of the invasive species around our pond. So this is our wildlife. And you can see we have a lot of wildlife. And so in the shiners, the chub, and the sunfish are all fish that live in our pond, which is really neat. And the picture of the frog is actually what we took when we just went outside to take data. And so we really, this isn't just like some wildlife that we never see. We really see a lot of this wildlife all the time.
Backside. I'm sorry. No, yes.
Yeah.
So it's one great blue heron that is around our stream, and that is unfortunately what's eaten a lot of our fish in our pond, including the goldfish.
Okay. So when we look at our stream, we try to improve our water quality in 2 different ways. So first of all, we try to improve the water that's going into the stream, and we try to improve the water that's already in the stream. So improve the water going into the stream. One thing we've done is we planted a riparian buffer around our stream. So this buffer around 2008, 2009. Buffer is made to stop erosion and to filter some of the water going into our stream. Because like we said before, a stream is made from runoff water. And the buffer also provides shade over the stream. And then another thing we do is monitor a CDS unit, we'll talk about more later. But the CDS unit basically also filters runoff water that's going into our stream. And then secondly, we improve the water in our stream. So one thing we've done is inserted floating islands into the pond, which we'll talk about more. And the plants on these islands absorb and recycle nutrients in our pond. So this is pictures of our buffer. So you can see that before the Genesis project, that's our pond. The pond was really barren. There's sunlight hitting the pond directly. There's nothing around the pond, and a lot of grass from the mowed grass would go into our pond. And after the Genesis project, we now have a diverse ecosystem of plants around the pond and they're providing shade. They're preventing erosion. They're really doing what they were meant to do. And so you can see some more pictures. This is our post pond site where we take data, and you can see here that this is a storm drain, which is something that we've been monitoring because it goes pretty much directly into our post pond site. And this is another picture of our stream, and you can see how much of a difference the buffer has really made on the stream. You can see how much different our stream is than before the Genesis project. And it's really evident from the pictures that the buffer provides shade over the water, and it provides a buffer for runoff. And so just because of the pictures, we want to look to see if this is reflected in our data. So these are our floating islands. So the floating islands are man-made islands, recycled plastics, and they float in the water in our pond. And we install plants on the island. So you can see the bottom picture is 2 girls installing the plants. And then the top right picture is an aerial view of our pond. You can see these are the islands. And we put these islands in 2012. And our hope with the islands is that the plants on them will absorb and recycle nutrients in the water like nitrates and phosphates, which we have in high quantity. So when we installed the islands, one thing we wanted to observe was the success of different types of plants on the islands. So one island contained edibles and medicinals. One island had native grasses, and one island had flowering plants. So these are the pictures of the islands right after they were installed. You can see the plants are really small. And these are the islands today. So the islands today don't just have medicinals, one have native grasses, one have flowering plants. Today, a lot of native species have gone onto our islands, like cattails, which you can see in the picture right here. And other native plants have gone onto our islands. And one thing that we're really happy about is that our islands don't contain any invasive species, and we're working hard to keep them that way.
We have one CDS unit across the street from our stream that's right at the foothill of Indian Hill. And pretty much what it is an advanced storm drain. It takes all the runoff water from Indian Hill and the rainwater and allows it to go into the CDS unit. And once it's in there, it forces the water to flow in a circular motion around the CDS unit, which drops all the sediment off to the bottom of the CDS unit and then allows water to flow through very small holes into a pipe right next to it, which allows the water to flow from there into the stream. But the only problem with the CDS unit is it's only cleaned once a year by the highway department of our town, and we believe it fills up a lot faster than that. So we plan next year to start recording weekly height increases of the sediment in the CDS unit in an attempt to get it cleaned more than once a year. And here in the picture, you can see them cleaning it this year. They clean it pretty much with just a giant pipe and a vacuum. They just suck all the sediment out. But if they can get it to do it twice a year, then that would increase the effectiveness of the CDS unit and therefore cleaning our water more.
And so another thing we do to just try to positively impact the water in our community is that we release trout. So each year, students in our classroom raise the trout from eggs to little fish, I guess. And then one day, new students come and release them into the local stream with them, and with representatives from Trout Unlimited as well. And so the New York University students, it helps to show them because our water will become more. And so the NYU students come here and show them how much work it actually goes into water clean. And so now we'll look at the data. So this is our graph of our nitrates since 2011 to today. And the light green line is all the nitrate data points, and the dark green line is the regression line. And so because the slope of the regression line is 0.002, which is positive, that means that our nitrates have been generally increasing since 2011 in our pre. And when you look at our post-pond site, you can see that the slope of the regression line is also positive. And so the post-pond nitrates have also increased since 2011. But when you compare the two, one thing you could see is that the post-pond slope is much less than the pre-pond slope. And so we believe that the post-pond nitrates have not increased as much pond nitrates because of the floating islands. And because the plants on these islands and the microbes in their root systems take up nitrates in the pond, and because the water flows from pre-pond to the pond to post-pond, by the time the water gets past the pond into the post-pond site, it has less nitrates. We're gonna work more on trying to see if this is definitely the reason why the nitrates have increased less in post-pond. So when you look at our phosphate data, so this is pre-pond phosphates, and you can see that the slope of the pre-pond regression line is negative. The phosphates have generally decreased since 2011. And the slope of the post-pond phosphates versus time is positive. So you can see that post-pond phosphates have generally increased a little bit over this time period. So this data was really unexpected because we were expecting to see a similarity to what we had in nitrates, where post-pond nitrates or post-pond phosphates would decrease more than pre-pond phosphates, or they would increase less than pre-pond phosphates, and because of the floating islands. And so the general increase in phosphates at post-pond may be an indicator, also like an outside factor impacting our phosphate numbers. Like, we have a few storm drains between the two sites, and the water coming in from the storm drains may be high in phosphates, and that's something that we're going to be monitoring more closely. But however, these two slopes are both very small, even though one's very small in the negative and one's very small positive. So it may just be due to error. And then also maybe due to phosphates being released from the sediment at the bottom of the pond, because phosphates get stuck in the organics in the mud at the bottom of the pond. But because the pond has so much of this mud, when phosphates are released and they flow into post-pond, that may influence our post-pond numbers. So this is our water temperature. So you can see the water temperature at pre-pond is generally decreased because the slope of the regression line is negative. And another thing you can see in water temperature is how much our water temperature fluctuates with the seasons. You can see how it gets almost at 25 degrees Celsius in the summer, in August, and it goes down to near zero in the winter, and it even becomes negative at some days. And so the seasons are something that really impacts all of data. So we have 4 seasons, and they're all very different from each other. And this is our post-pond water temperature versus time. So again, you can see that water temperature is generally decreasing, and you could really see the cyclic changes in our water temperature because of the seasons. And so when you compare the two, you can see that they're both decreasing at both almost the same amount. So we believe that this is due to the buffer we planted around the stream, because that buffer has been growing steadily since when we planted it in 2009, and it's been providing more and more shade over the water, and the shade over the water cools the water. And so that's something that we're really excited to see, that our water temperature has generally been decreasing. And so this is another temperature graph. This one's a little different. So this graph is a ratio of pond to post-pond. And so if the ratio is 1:1, all the data points would be on that red line. But you can see after the 13 degrees Celsius, which is where the green line is, that the data points tend to be above the red line. And this is an indicator that the post-pond temperatures, when the temperature is 13 degrees Celsius, post-pond is hotter than pre-pond. And so this means that in the summer, the water at post-pond is generally warmer than the water at pre-pond. And we believe this is because as the water flows from pre-pond to post-pond, it goes through the pond. And when the water's in the pond, the sunlight hits it and it warms up before it flows into post-pond. So this is our dissolved oxygen for pre-pond versus time. And this is our post-pond dissolved oxygen versus time. And dissolved oxygen is another thing that shows the cyclic changes because of our seasons. You can see how in the winter, dissolved oxygen gets much higher, almost to 14. And in the summer, it decreases a lot. And so this is just shows that dissolved oxygen decreases in the summer when the water's warmer, and it increases in the winter when the water's colder. This is alkalinity. This is pre-pond alkalinity versus time. And this is post-pond alkalinity versus time. So when we were first looking at the graphs, we were really surprised to see that there's a cyclic nature in alkalinity too. you can see more on pre-pond how it's increasing in the summer and decreasing in the winter a lot. And so we did some research and we believe that the alkalinity roughly does this because in the winter, because of snow and snowmelt, our water levels are much higher. And then in the summer, the water levels are much colder, or the water levels are much lower. And so in the winter, when there's more water in the stream, the alkalinity is going to decrease because of all the ions in the water are still staying the same. And then in the summer, when there's still the same amount of ions but less water, the concentration will increase. So this is our salinity graph. So salinity is something that's really important in our stream because our stream is right next to a road. And in the winter, when it snows and the roads get icy, our town puts rock salt and brine onto our roads. And since our site is so close to the road, the salt inevitably comes into the site. And so salinity is something that it roughly increases in the winter and decreases in the summer again because of the salt that's put onto the roads. And this is something that we want to look more into, like how we can try to improve our site's salinity and try to maybe influence the town to do something different to decrease salinity. And this is our pH graphs for both pre and post pond. And our salinity is our pH, is almost always 7.5 or around 7.5 in both sites. So it's good to see that pH has not really been changing or fluctuating too much. And so in addition to chemical testing, one thing that we do is test macroinvertebrates in our stream. So the macroinvertebrates are larvae that live on leaf packs in the water. And so leaf packs naturally in the water are leaves that like hit submerged rock and stop there. And then the macroinvertebrates use the leaf packs in the water to live, to hunt, to feed. And so what we do to test macroinvertebrates is we put leaves in an onion bag and we put them in our stream and we leave them submerged there for a month. And then when we take them out, we count the number and the type of macros in each state and try to compare them. And so this is our macroinvertebrate numbers from pre-pond. So you can see the big picture with all of the Petri dishes is all of our macros when we tested, and the picture on the left is a picture of a caddisfly larva that we found. And then these are our post-pond numbers. So you can see we have a lot more numbers for post-pond. We have the picture on the right is another larva that we put under the microscope to look at. And so the reason we test macros is because certain macros are pollution sensitive, which means they can't live in a stream that's too polluted. And so we tend to really look for those macros when we test our stream, because if we find that shows that pollution sensitive organisms can live in our stream and the source is not polluted, it's not impacted. And so we circled all of the macros. So the green one is a pollution sensitive organism. The orange one is a pollution semi-sensitive organism, and the red ones are pollution tolerant organisms. So you can see from the picture that we have a pollution tolerant organisms and not too many pollution sensitive. And so from this we made the conclusion that our stream is definitely impacted, and it's impacted at post pond, but it's impacted at both sites. And it shows that even though our chemical data has been showing that our water has been getting healthier, we still have a lot of work to do in improving our water quality.
So why is the water in our stream so important? From our stream, the water actually ends up flowing to the Croton Reservoir, which provides 10% of New York City's drinking water every year. So the water starts in our stream in Mayapack High School, goes down the river into the Musket River, where we actually release the trout. Then it goes down to the Croton Reservoir all the way over here. And then after the Croton Reservoir, it ends up leading into the Hudson River. So during our time here with the Genesis program, we've done a lot of different collaboration, including the Cornell Cooperative Extension and the Watershed Agriculture, which we worked with two people, Jen Lerner and Brendan Murphy, to go over the invasive versus native species at our stream, different procedures that we can use to get rid of some of the invasive and replace them with different native species to increase the effectiveness of our buffer at our stream. We've also worked with the New York State Department of Environmental Conservation in order to do the trout release, including New York University. We did the trout release with both of them. And then the Carmel Highway Department, we work with cleaning out the CDS unit and measuring the height of the sediment in the CDS unit. And we also work with different schools around the world, including a school in Croatia, where we talk about with them our data. And we've actually recently done a Zoom conversation with a few students at their school just to talk about different things and the differences at our schools. One thing that we've noticed about different schools is that how lucky we have it. Our stream is actually right in front of our school. It's a 2-minute walk, but the school in Croatia has to take a 20-minute drive every single day just to get to one of their sites. So we've really realized how easy it is for us and how lucky we are to have our stream so close. And then of course, every single week we work with the Genesis Pro collaboration group in our school and through the GLOW program.
Yeah. So the New York State Department of Environmental Conservation actually donated some plants to us that we planted around our stream to help our buffer when we were originally doing that. And also from NYU, so Dr. Karen Moore helped us put together some of our data. She made that 1-to-1 temperature graph that we looked at. And Dr. Katie Schneider is the professor of the NYU class that comes to MAPAC every year and releases trout with us.
So some different recommendations for GLOBE is the first thing is we've noticed on the GLOBE website, if you plug in that your water is frozen, it does not allow you to plug in any other data according just to the website. And every single year our water freezes over in the winter, which forces us to break through the ice. But we have to lie to the GLOBE program and tell them that our water is not frozen just in order for us to be able to plug in data. So a new page that allows us to plug in data for the frozen water would be great. And also at our site, we take a lot of other data that isn't on the GLOBE website, including specific conductivity, chlorides, turbidity, flow rate, and phosphates. So just adding those different columns to the GLOBE program would allow us to just have them make the graphs for us instead of making the graphs and the data charts ourselves. So conclusion, can students have a real impact on water? We believe yes. Quantitatively, the things we've done at MAPAC, like the buffers and islands, have made a very big positive impact on the data, specifically nitrates and temperature, as shown in the graphs. And then qualitatively, the Genesis project has shown hundreds of students the importance of water quality and the connection, how it connects different communities' waters, and why improving water health is so important to communities as a whole. Through collaboration, we have taken the Genesis program around the world.
Thank you.
Thank you. That's it. Thank you.
Wow, that was amazing. So that was probably one of the most comprehensive research projects I've seen in a long time. And I especially like the combination of that plus the collaboration with other schools and looking at other data, as well as, you know, understanding what some of the limitations are and having some recommendations for the GLOBE program. So we'll definitely be sure to, you know, follow up with the GLOBE program and let them know exactly, you know, what your thoughts are on this, and you know, then we'll see where we go from there. But yeah, great job. You know, I love the graphs are great, and you just didn't take the data, but you made sense of that data, which is what we're striving for here, because anybody can take data. You know, you can hand somebody an instrument and they can take the data, but in order to analyze the data is one thing, but then also to take it the next step and figure out why this data is important and who are the greatest beneficiaries of this data is such a vital thing. And you guys covered that, you know, across the board. So, you know, my hat's off to you. I'm not wearing a hat, sorry, but you know, yeah, great job. Awesome job. So I'll open it up.
I'd like to add.
Yep.
I just gonna say, I want to add to what Brian said. You know, we've been doing this now for a couple of years, and Brian's really spearheaded this idea of having the students be the ones to do the presentations. And you know, we kind of started off with students having very, very specific information they were providing, and we gave them the kind of the template. And now it has been so amazing to watch this evolve. especially with these soda webinars, to where you guys are totally driving it. And not only are you driving it, but you're just rocking in your ability to be able to be a storyteller, to convey what you've done and why it mattered to others. And, you know, that's probably the most important part of being a scientist and science, is being able to convey what you've done and what you've learned to other people. Otherwise, you may know it, but it kind of stops there. So super, super job. Just really impressed. You've set the bar really high.
Thank you.
Thank you.
Yeah, a couple comments from the chat. If you haven't seen them, Lynn Powers said, I agree with Brian, very impressive presentation. Marcus Euster from Switzerland, who's on right now, he said, your presentation was very good. I would like to be a student at your school. Your floating islands are very cool. I was just reading about a similar startup project here in Switzerland. So very cool. And the questions are, one question he asked, how often do you take the measurements?
So we've taken measurements once a week for the past like 20 years.
Okay, yeah.
Because of the ENSO campaign, we've been taking data 3 times a week for the past month.
Uh-huh.
We
Awesome.
made these guys do a lot of work, and then they were not happy when I told them all this stuff. What's happening? Okay. I have a young lady here who's part of the ecological research class, Emily, one of my former students. And why don't you just kind of describe, you were in charge of nitrates?
Nitrates.
Okay, so she can describe, you know, it's a class that is an elective, I think, right?
Yeah, we meet like every other day. And basically during our period, we have to like go out, we had little buckets of water, and we have to collect the water from pre-pond, post-pond. And like, even if there was like ice, like one time me and my friend had to literally tried to break through the ice. Someone in the class also had to like actually break through it. We were able to get water that day because of that. And basically, like I did nitrates, they also had people do like pH. I think someone did alkalinity, we did transparency. Some girls like took pictures, like I think every day of the clouds, that's the actual site.
Now, as far as like your intake, 'cause I have to try and explain a little bit about what Alex said, putting in data. But, you know, the integrity of your data, like how did you make sure that the nitrate data was good, that it wasn't?
Because we used like a standard and we compared them the standard to what actual like the reading was on like the.
Okay, so calibrated the equipment
Yeah.
before you used it. Okay, good. And then, yeah, once they did that, and I watched them run the test, they were using colorimeters and all. And it was amazing how well they handled you know, the equipment, about keeping it clean. We explained to them that fingerprints could throw off your data and all, but they used, what was the standard you used?
We used a 10.0 for most of the year, but then we ran out, so we had to
10
get
buffalo chips, 10 Corvettes.
10 milligrams per liter.
Okay, 10 megs per
Yeah.
liter.
And then we had to, then halfway through a year, we had to switch to a 1 because we ran out of the standard, 1 milligram per liter.
Okay, good,
Halfway
good.
through the year.
And we're hoping Emily will join us next year when these people graduate, and they'll come in. And Alec explained about the project, you know, Genesis continuing and all. I know Mr. Rizzo would probably love to explain a little bit about his part in this whole collaboration. Right, Mr. Rizzo? Did you? Oh, wait, that's right. You don't have a mic. You got one that can, there we go.
Surprised we're all in the same room. I feel like we're doing the Brady Bunch. It looks like, you know, we'd like to continue on this next year, focusing on a bunch of different topics. What was your question again?
Just is this thing going to continue? Is it, you know?
Yeah. We'd really like to continue this on because I'm fortunate we're on a teach living environment, and this is a hands-on application to what we teach. And it applies to environment. We have applications in the chemistry classes now, and it's just one of those things where it's an absolute blessing when you've got kids like this that are just driven and they can apply real world scenarios. So we're most definitely be at lower. In our room right now, we've got about 10 kids. They're all underclassmen. We've kind of forced them to be here, but they're all watching the presentation. I'm like, I can't believe we're doing a webinar. So they're all here. We're all wearing our tie-dye shirts. We had a big old family activity on Friday. But so yeah, we'll definitely be continuing this forward next year.
And it's been amazing. They've really gotten a lot of students involved with this. The one thing I guess I wanted to ask, and this is something I don't even know myself, and is they do, was explained earlier that they do have a place that if you go out to your stream and it's frozen, you just put down frozen. What they have been doing is if it's frozen, there's still water underneath. So they've actually been breaking through the ice and then collecting that water and testing it. On the Globe protocol, do you know if it's frozen? Do you just report that and don't bother testing the water underneath, or?
Yeah, historically they have it set up that if, by looking at, doing water chemistry things, if the water's frozen, and it comes down to a safety issue as far as like breaking through the ice. The same thing happens with the soil moisture measurements. If the ground is frozen, they don't want you to, break up the soil, or, could be, tools could break or whatever, so, and plus, I guess they don't want a lot of people outside when it's, 0 degrees, taking measurements. But, I say, you gotta do what you gotta do, because as far as the option for soil moisture, it's almost impossible to do when the soil's frozen. But with the water chemistry, because I know some other folks, and I won't mention anybody by name, Mr. Bauman, he's broken through the ice and taking measurements, which is perfectly fine. It's just on the protocol; it's not listed as that. But it's all in the pursuit of good science. So if it's done safely and if it's done according to the protocol, other than just breaking through the ice, I mean, I say go for it, because it's just a safety thing. So you have to be super careful.
All right. Now I'd be interested to know, like, does Jeff, like, you've done the same thing, Jeff, where you've actually broke through, but then, recorded the data. I mean, I think I told them to, if it's like that in the metadata, just, record the information, but put down that the water was frozen. We had to break through it. I don't know. Does Jeff do that? Are you still with us, Jeff?
Yeah, I'm here. I'm sorry. I've got my 6th hour in the room. So, if I heard you correctly, the going through the ice. Now, my daughter, when we were taking water samples, we only went out when we had like 6, 7, 8 inches of ice, and it took a little while to spud through it. The ice was so weird. It was thick and then it would break up, and it was thick and it would break up. We didn't go out if it was too dangerous, but I'd have to ask my daughter Leah, because she did the project, but she actually found, I think it was conductivity and dissolved oxygen dropped way out when there was presence of really thick ice. And so at first she thought she was doing something wrong, but when she did more research, she actually found out that no, that's normal, So did I answer your question? I'm sorry. I'm jumping in and out. So
Yeah, no, listen, we were just curious as to how you guys do it. I agree with Brian that, if it was a safety issue, we wouldn't be having the kid, like on the pond, for instance, I wouldn't have the kids walking to the middle of the pond. It can be 6 feet deep. So if they break through and they go under, yeah, there's the end of the Genesis project, right?
And we did.
well,
What did you guys do? You went on the
I would get in a lot of trouble here at Shoemate too. We have the 2 ponds out front that my students in 4th hour study. And basically in the wintertime, they just went to the edge of the pond with a spud, and they would bust the ice up and take a, can out, or not a can, but a mason jar of water. So
if it does break through, if you fall through, you're only going to be in knee deep
But the
water.
sediments would
But then they also worried
air
about
the data.
if they're breaking through the ice and stirring up all the water and getting the sediments kicked up, and then they grab the water sample, you're going to get information that's probably not going to be scientifically legit. So it's a lot to think about. You're right, and it's interesting as to how we.
But definitely safety first. I mean, that's the safety first for sure.
No question. Yeah.
Yeah.
Well, we haven't lost any students yet. That's why it's up to Mr. Rizzo to
Yeah.
keep
Yeah.
that streak going. Right?
Yeah.
You're right. Well, the Hudson, when we go down to the Hudson, that's when it can get interesting.
Oh, yeah.
Swimming. So I'm just thinking, where's everybody, like, you guys are graduating, right? Sydney, Tyler, Alec, where are you all off to, and what are you doing? And what are we doing at those 3 universities? you into this group. Jeez, yeah. I thought we only had science kids in this group. so, so yeah, luckily we get all group. And we've got Genesis. How many in the Genesis group, Mr. Rizzo? I think it's a bunch here. Right? Is this all the Genesis group here? There you go. You want to see the Genesis group? That's a Genesis group. Wave high. There's a Genesis group. Kids that are, okay, in the program taking water quality after school and not getting paid for it. But yeah, listen, Jeff, I also want to thank, since Jeff is here, and I wish, like Darren, a couple of the others, we haven't forgotten the data. I'm going to be taking the data. We got the data from Croatia. I know Gary in Pennsylvania has collected data, and Chris in Connecticut as well. So we're going to be getting that data probably over the summer and seeing, you know, what to do with it, how to compare it, how do you use all this different information from these different areas. I know Cindy had mentioned Dr. Karen Moore. She's kind of our information guru. So I want to see if I can go up and talk to her a little bit about, you know, what's the best way to try and use it. Can you even use the information? I don't know. This was totally an experimental thing. So I appreciate, you know, Jeff, especially you guys and the ones that participated in giving us data and, you know, what we can do with it and how to use it. That's, and if you guys have ideas, please feel free to pass them along.
All right, does anybody else have any comments or questions for the students or teachers?
The one thing I know that makes the two things that Sydney was talking about, phosphates and nitrates, a little tricky is the nitrates are soluble, so they just stay in the water. As Sydney had said, the phosphates, they tend to cling to organic materials. So when you're testing what's called orthophosphates, you're just testing the phosphates that are in the water, not the ones that are stuck to the organics. To do a good job with phosphates, you have to actually acid digest it, which can, yeah, get a little tricky when you're boiling acid and the fumes and stuff. So that would be an interesting thing to take a look at.
Yeah. Could you speak a little louder? It's hard to hear on this end.
Has a question?
Okay, here.
There you go. Now go again.
Mr. Rizzo wants to know if Globe has a Twitter handle, and also if Brian and Doria and you guys have Twitter handles.
Yeah. So for Globe, you can just it's it's at, I think it's a Twitter, Dorian, at Globe Program. I think that's what it is.
Sorry, I had to quickly look for my unmute. I believe that you're right. Well, you keep talking, and I'm going to go ahead and see if I can find that.
Yeah, I think it's at Globe Program.
That sounds right.
Yep.
Now
my Twitter handle. Oh, what is my Twitter handle? Jeff knows it. Oh, it's at RipCurled1, RIPCURLED1. That's just my personal one. Yeah.
For the older members of the group, what the heck is a Twitter handle?
Twitter handle is basically if you have a page created on Twitter, that's the way you can tag people. So whenever they post something, if they put your Twitter handle on there, it'll then show up on your page.
This is why I miss hanging out with young kids. I've got one next to me explaining to me on our phone what's going on. So thank you.
Yeah.
Do you have any hashtags or no?
Yeah, it's hashtag Globe Program. You can do hashtag NASA, hashtag Globe Program, hashtag NASA.
Yeah, Brian, I'm sorry, Jeff, I know, has the Getting Science Done.
Yep. Yep, hashtag Getting Science Done. That's a good one.
Yeah. Oh, wow.
Hey, can I ask a question real fast? You guys, okay, we just finished up a sea lamprey study here. It's called the SLIME program, which is sea lamprey in Michigan education. Those things are nasty. Do you have a problem with those in New York too? Is that like I mean, I'm just shooting from the hip here. I don't really have too many questions, but we just finished that. The kids thought it was crazy, but Do you experience those at all?
Well, the lampreys, no, but you guys just took a walk, Sydney and Alec, I think. Didn't you just take a walk with the plant invasives? You want to expand on that a little bit with Brendan, I think, and Jen?
So, no, we don't have those exact same things, but we do have other invasive plants like the mugwort and the bittersweet that are taking over parts of our pond, and also Phragmites that are taking over big parts of our pond and our pre and post pond areas. And we've been working really hard to try to take them out using different methods. Like I know in past years we've tried to take the Phragmites out by covering them with plastic bags and tarps. Unfortunately, that didn't work as well as we hoped. And also to get the mugworts out, we're trying to plant a taller shrub over the mugwort in order to reduce the amount of light that hits them, and then eventually they'll die out by themselves.
And what about, like, remember what, like, I think, who was it, Brendan said, like, finding the plants and snapping the ones that are next with the invasives that are growing next to it?
Yeah, we've been trying to go around and just like snip the invasives and not try to grab their root systems out, just try to cut them down. Like we use that in Phragmites and we use that in bittersweet.
So in other words, if there's a native plant, right, growing in the middle and then invasives around it, you just cut back the invasives and hope the native gets big enough. So yeah, mostly, Jeff, to answer your question, the plants are our big issue here with invasive species, not so much the fish, although goldfish. we have firemen's, what are the firemen parades or firemen fairs or whatever. And of course, everybody wins a goldfish. So once they decide they don't want to bring it home, they find the nearest pond and dump it in there. And the next thing you know, we've got lots of goldfish swimming around in our water.
I used to just give it to our cat.
Well, we're gonna have you come down and give a little talk at the fireman parade. Tell them that you find a cat.
So hey, before we finish up, also I should mention that in the chat, if you take a look at that, Marcus from Switzerland also mentioned that, you know, as you observe around all year, do observations all year, you might want to participate in his Seasons and Biomes project. It's a really cool project. It's been going on for a while now, so you can check that out. And it looks like there's a site for Seasons and Biomes in Fredonia, New York. So yeah, okay. Seasons and Biomes is a really cool program, and it's been around for a while. So yeah, and I know Marcus is leading that. So, you know, you're in good hands with Marcus with that project, because I've seen a lot of the stuff it's done, and it's a really great project.
Yeah, if he could, I mean, you put my email down earlier. If he could send me the information, and then, yeah, I think between Jeff's project, Marcus, there's probably a lot of stuff that's being done. If we can somehow tie all of that together, that would be a great thing.
Yep.
And then Laura, I think is it Ohio? Laura's got the story.
Yeah, the H2U project.
Yeah.
Yep. Yeah, that's a water stories.
Okay. Yeah.
So there's a global map on that page. Dorian, can you pop up that URL in the chat, the HCU project? So that allows you to share water stories from your local environment around the world. So there's ones coming in, you know, from all four corners of the planet. So it's really cool stuff.
Okay. We'll see if we can try and link all these things together, and it might turn out to be a very nice collaboration. So. Yeah.
So with all that said, I'll give you the heads up. What's happening now is we were notified today that after the ENSO phase 3, we're going to be focusing on a new campaign, but be using a lot of the same protocols. That's just progress, okay? And it's going to it's basically going to focus on a hot topic right now, mosquitoes. But with mosquitoes, we have, you know, now submissions from, you know, all over our directorate that focus on things like soil moisture and water quality, you know, precipitation, and all these different protocols that are part of the ENSO campaign will be part of this mosquito campaign. So that's just progress. And, you know, Dorian and I were on talks with the powers that be today, and we're going to be using the same type of, you know, the campaign is going to be using kind of, you know, the same way we've done ENSO. It's just a new topic, you know. And if you guys some of you, I know Jeff was here from the early starts of the SMAP campaign. When the SMAP campaign ended, the measurements were then pulled into the ENSO campaign, what was actually called El Nino at the time, and then it became ENSO to include El Nino and La Nina. And then so all the measurements that are part of this campaign, many of those will be pulled into the mosquitoes campaign. And when we say mosquitoes, we're looking at adult versus larvae. So we're looking at water in our environment anyway. So it's just another way to refocus the direction based upon, the current issues at hand. Because a lot of the Globe the Globe campaigns do that. The soil moisture was a big thing when the SMAP satellite was launched. And then we got into a really strong El Nino period on Earth. So it became the El Nino, then the ENSO campaign. So now we have a lot of stuff going on with students, teachers, and citizen scientists for mosquitoes. So that's going to be kind of the backbone that's going to be the backbone overarching theme, but it's going to include all of these things that we're talking about today, the presentations that we've had from students and educators, throughout this last phase 3. So, in the next month or so, it's going to not be ENSO anymore, but towards the, I'm going to say, early August timeframe, it's going to phase into mosquitoes, and the title hasn't come up yet. So, because we just had our first talks about it today. So, you heard it from the horse's mouth, but Dorian has done a lot of extensive work on NASA and Globe and the mosquito habitat mapper and the mosquito program with the Department of State and some other groups. So she is going to be leading this campaign, and I'm going to be her cohort on the side. And but Dorian has done so much with mosquitoes. So I'm there because I've been working with the folks doing a lot of the water stuff. So, don't feel like anything's really changing other than the structure, not really the structure, the theme, because we're going to include a lot of the same protocols. It just won't be ENSO. So it's just going to be a new campaign. We haven't figured out the name of it yet, but it's something mosquito related. So if Dorian wants to add anything in there, cool.
Can Dorian recommend the best mosquito repellent to use?
Boy, I wish I could. It's interesting as you get into learning more and more about mosquitoes and other vector-borne disease, you kind of find out that so many of the little things that we try to do, like the spray and other things, are like putting our finger kind of, in the dike. And because some mosquitoes, in the same way as some viruses, simply change. They're able to kind of modify themselves, and they're no longer, repelled by some of those things. There are some natural ways in which some people swear you can get rid of mosquitoes. I was just in Lima, Peru. Some people were talking about some of these natural plants that they plant, and they swore that those worked to get rid of mosquitoes. But the big thing that we're trying to push that really is the best thing that we can do to try to reduce at least the threat of mosquito-borne disease is to, anytime we have water sitting around, outside, like you might have dishes out there for dogs, or buckets of water, or maybe right now we've had a lot of rain, and the top of the sandbox that I have for my granddaughter has a bunch of water. I just have to make sure that every week I empty the water sources and put in new water so that we don't, inadvertently cause more mosquitoes to be, to be hatching. Fortunately, in the United States right now, most of the mosquitoes that we have are not transmitting disease, but we're beginning to be pretty, concerned that as we have increased globalization and more mosquitoes are able to they don't have to have passports, they just fly over the border, and they sometimes will get in trucks and cargo and on boats. So we're worried that we could start to see the transmission of the diseases that mosquitoes spread. And that's partly why we're modifying our focus. The Department of State has become really involved in the whole Zika, concern about Zika and eradication. So we're going to start to involve, our entire Globe community in seeing how you can collect like precipitation data, soil moisture data, and then also compare and contrast that to what's being found in your region with mosquitoes, the prevalence, the types of diseases that are being transmitted. So it'll be a different focus, but still, mosquitoes, the primary factor that results in having mosquitoes around is water. So it'll still be looking at water in our environment, just with even more of a kind of a narrow focus, and that is on mosquitoes. But it should be pretty cool.
All right. Anybody have anything else?
I just want to once again say a huge round of applause for our student presenters today. Just totally awesome.
All right. That's right, and the Genesis group and all. Yeah, just the one thing I'm thinking of is with the mosquitoes. You may want to include just mosquitoes and macros maybe, because if sometimes you have a problem finding mosquitoes in the area, or just maybe make it a more of an invert thing with mosquitoes as the main focus, but then what other macros might be around. It may expand your ability to get people involved. Just a thought.
Hey, we really want your guidance and suggestions, and you're absolutely right. One of the things we want to do is see ways that we, just like we did with water in our environment, looked at all the different globe protocols that could be a part of how you can gather your data. Macroinvertebrates certainly gives us a lot of information. And the other thing is, it would be nice to see students starting to do some research, like going into their public health, going into their public health records, talking to hospitals or looking at the records for their area and seeing what are the diseases that are related to mosquitoes that have shown up already, and maybe compare and contrast that to some other places, some other countries, some other cities around the world. That would be a really neat collaborative activity. What's happening in Ohio and New Jersey or Michigan, what diseases are they starting to see related to mosquitoes, and compare that to what are they seeing in Rio and other places. It'd be neat to get that type of data, and it doesn't all have to be solely based on globe protocols. It's nice to actually integrate that, as scientists do, with other data sets that are out there as well.
Well, it's definitely a hot topic. I know my brother-in-law is down in Florida, and he got eaten alive by the mosquitoes down there because of all the rain they just had the past week. So he'd want.
And another thing that's really big, and we've just recently here in Maryland had some advertisements come out, not advertisements, but public health announcements, is West Nile virus. That is all over the United States and is a huge problem. So some mosquitoes are just nuisance mosquitoes and they annoy us, but then other mosquitoes can be transmitting disease. And it's really easy, actually, just looking at the larva and having a little magnifier that goes on your cell phone. You can identify which species of larva you have. And at the larva stage, they can't hurt you. They don't even have mouths, they can't bite. So they're kind of cool to work with. So
Yeah,
we'll be doing a lot of training on that.
Yeah, one thing I want to reiterate is that, even though, you may want to pick up doing some mosquito measurements, please don't stop doing the measurements that, that you've been doing as far as water quality, precipitation, and soil moisture, because all of those, as Dorian mentioned and I did before, all of those are vital to understanding where these vector-borne diseases are, where they can be hanging out, so, where there's standing water, there's mosquitoes, and there you can look at soil moisture, water quality, water temperature, all that stuff. So yeah, it's just yeah, I've said enough about that. So yeah, so I just can't reiterate it enough though, that all the measurements matter.
Sounds good.
All right. Anybody else? All righty. Well, thanks so much. And I'll shoot an email out once I get the recording and everything up online. Once I get it back from Zoom, when I get the recording, I'm going to stop recording right now.